Okay, so we're looking at this 5 what, guys? Did you want to?
B and C. Or
Okay.
just B, and maybe I'll be able to figure out what C is doing.
Okay, so yeah, let's start with 5b. So we're trying to, oh god, we're trying to Laplace transform this function f of t. Can you guys mute your microphones unless you're gonna talk? Just so we don't get lots of smashing. All right, so we're Laplace transforming f of t, which really should be the integral of f of t times what? Okay, now you're going to have to unmute your microphone to answer a question.
Oh, technology.
F of t e t.
E close.
Negative st.
F t at negative st. Yeah, that.
Okay.
Negative st.
dt, right? And what are the bounds on that integral?
0 to
Infinity.
4. 0 to 4.
Okay.
Infinity.
What?
Yeah, so the definition of the Laplace transform, right, is the integral from 0 to infinity of f of t times e to the minus st dt. Now, the problem with my f in this case is that it's only defined, it's kind of oddly defined, right?
Yes.
Yes.
Okay. So let's split it into the two pieces that it's defined on. So it's defined from 0 to 4 as 1, right?
Yeah.
And that's still times an e to the minus st dt.
Mm-hmm.
And then to that I need to add the rest of the integral, which is going to be from 4 to infinity of t e to the minus st. Come on. Good damn it. dt. Right?
Yeah. Mm-hmm.
Okay. So then we need to say, all right, so on that first bit, right? What do I get?
Negative.
1 over s.
I get negative 1 over s times e to the minus st evaluated from 0 to 4. And what are the bounds on that?
S cannot equal 0?
Oh, no. So that's their domain restriction, right? So that's,
Oh, yeah.
this thing converges for s is bigger than, well, this thing converges for s is whatever, as long as it's not 0, right? But the bounds, the 0 and the 4, are those about s's or are they about t's?
These.
Good. Okay, writing on this is just a little bit more challenging than I could wish. Okay, so that's the first integral, and I'll have to do that evaluation. And then the other piece is plus the integral from 4 to infinity of t e to the minus st dt. Right? I just haven't dealt with that at all yet.
Yeah.
Okay, so... Oops. All right, so I'm going to run off into the margin here. And I'm not, frankly, totally sure how to run off into the margin. Oh, great. Okay, so I'm going to run off to way underneath this thing. And I just need to integrate t e to the minus st dt.
Mm-hmm.
And that's What's your technique for that?
Looking at the tables.
Looking at the table?
Mm-hmm.
Oh, like in the back of the Calc 2 book?
Or the back of the handout that you gave us.
Okay, so if you're gonna look at the tables in the back of the Laplace table, then you need to recognize that this thing looks a lot like the Laplace transform of t, right?
Yeah.
Except it's not.
Mm-hmm.
Why is it not the Laplace transform of t?
Because it's not 0 to infinity.
Good. It's the bounds are wrong, right? So
Yeah.
the Laplace transform of t would have from 0 to infinity of t e to the minus st dt. You guys kind of with that?
Yeah.
Okay, so since the bounds are wrong, I have kind of two options. One option is I can do what I was kind of starting to do down here, which is this like manual integration thing,
Mm-hmm.
which frankly kind of sucks. So I'm with your idea being a little better, but I need to adjust the bounds, right?
Yeah.
Okay. So what I'm going to do instead is dump my kind of manual integration idea. And I'm going to think to myself, all right, look, I need to adjust the bounds on that thing. So I'm going to do that with a u substitution, but I'm going to make it a t hat substitution just because I want to be a little bit explicit about what I'm trying to do. So I'm going to let t hat be t and something to do with 4. So if the bounds on my integral start at t is 4, and I need them to start at t is 0, what's the adjustment I need to make?
-4.
Yeah, I think I need to let t hat, right, my new t, be the old t minus 4.
Yeah.
You guys feel me on that?
Yeah.
Okay. So then I'm going to make that substitution. So I'm going to have, all right, so I still have my minus 1 over s e to the minus st evaluated from t is 0 to t is 4. Right, I just haven't adjusted that piece at all.
Mm-hmm.
So should be noted, this thing here only applies to this integral. Right?
Yes.
So I'm adding, and now I'm going to go from, all right, so when the old t is 0, the new, or when the old t is 4, the new t is 0, right, which was the point.
Yes.
When the old t was infinity, the new t is
infinity minus 4.
good, which I'm gonna denote as infinity.
Fair.
And then in here I need the old t, which is
T minus 4.
Close. This thing needs to be the old t.
Plus 4?
Yeah, which is the new t plus 4.
Yeah.
And then I have e raised to the minus s times. And then
T plus 4.
Yeah, and that's going to be again a t hat plus 4. And then I have a d.
T hat.
Yeah, and the only way I'm getting away with that, right, is that given my substitution here, dt hat is equal to dt. You guys see why?
Yeah.
So I'm just doing a plain old U substitution, right? It feels a little different because what I'm really after isn't adjusting the thing in the integrand it's not adjusting the thing that I'm integrating, right? It's that I'm trying to adjust the bounds, which feels just a little funky. So now I think I've got, all right, let me deal with that first part again. So in the first part, I was doing from old t's, right? 0 to 4, evaluating this thing. So I think I get a minus 1 over s e to the minus 4s. You guys with that piece?
Yeah. Yes.
And then I have a plus 1 over s e to the
Zero, right?
Good, e to the 0. So that's of course 1.
Right.
So I can just dump it. So that's this stuff became all this stuff. And then I have a plus. And then this guy is a bit, now it looks more like the Laplace transform I wanted. But some stuff got weird. Right?
Yeah.
Okay, so the stuff that got weird is that now there's this t hat plus 4 bullshit in there. Right? So what I'm going to do is I'm going to deal with the exponent in the e first. So I have the integral from 0 to infinity. That's good. That's bounds adjusted the way I wanted them. And then I have t hat plus 4 times e to the minus st hat times e to the minus 4s dt hat. Does that exponent rule make sense?
Yeah.
Okay. Did I lose anybody?
It's hot, so. And please feel comfortable to come in.
Okay, so I think then that I need to get this part out. Is that okay?
Yes. Yeah.
Why?
Because it's constant.
Good, because it's constant with respect to t hat, right? So I'm going to pull that part up front. And so I'm going to have minus e to the minus 4s over s plus 1 over s. That's just that stuff from before. Plus e to the minus 4s times the integral from 0 to infinity of t hat. Oops, I got ahead of myself. Okay, and then I'm going to distribute. So I got t hat e to the minus st hat dt hat plus the integral from 0 to infinity of 4e to the minus st hat dt hat.
Ugh.
Which looks schnasty. Yeah?
Yes.
Okay. So this 4 is a constant.
Mm-hmm.
So you can pull it. This part here. Oops. I don't know why the mouse wheel's inverted in here. It's very strange. That part here is the Laplace transform of t hat. You guys see that?
Yes.
And then I can just look up in the table like you wanted to. And then this part here is 4 times the Laplace transform of
1.
1. Perfect. You guys with me?
Yeah.
All right, so I'm going to get minus e to the minus 4s over s plus 1 over s. That shit was, oh, for God's sake. All right, we're going to learn some hotkeys eventually. E for eraser and S for pen.
That makes sense.
All right, plus e to the minus 4s. All right, and then the Laplace transform of t is what?
Is n factorial over s to the n plus 1.
Okay, so I'm going to look at this thing here and think to myself that's
1 over s squared.
t hat to the 1. Yep.
Yeah.
So I'm going to get 1 over s squared.
Squared. Well, you know.
Yeah, I'm sorry. Squared, of course.
You're forgiven.
Okay. Plus. Oh, whoops. I lost a set of parentheses earlier. See those? That was my bad. So I got e to the minus 4s times 1 over s squared plus 4. And then I need the Laplace of 1.
1 over s.
Perfect. 1 over s. And then a little bit of simplification is possible here, but I am not going to do it because I am tired of writing on this thing. Another option. So
Okay. I get it.
I'm gonna jump ahead a section just for quicksies. Maybe I'm not. How are you all feeling about this? Was this confusing enough?
Yeah, so this is pretty good.
I get it.
Reasonably to follow.
Okay.
Yeah, actually, this step has been pretty intuitive.
Oh, good. Okay. So let me show you the easy way then. Since you guys are probably getting this stuff pretty well, I think. The easy way is to start back over at the beginning and look at this silly function that they had at the beginning, right? This is 1 for 0 is smaller than t is smaller than 4. And it's t for t is bigger than 4. Right?
Yeah.
Okay. So, oops. I have real problems moving this screen around. Is there an obvious method to slide to the side? Oh. Okay, cool. All right, so I'm going to look at this and I'm going to think there's an on-off switch type of thing going on here. And so what I have is that between 0 and 4, 1 is on, right? So I'm going to think about a light switch function. So I'm going to define u of t minus a, which is going to be 1 for t is smaller than a, and oops, sorry, I said 1, and I meant eraser, pen, and I meant 0. So it's off until we get to time a, and then at time 1 we'll turn it on, or at time a we'll turn it on. Does the idea of that function make sense?
Do you want to restate it one more time?
Yep. So u of t minus a is 0 for t is smaller than a.
Okay.
And then it's 1 for t's bigger than a. And so graphically, that looks like a hotkey for changing color. That looks like maybe a is a value over here. It's off until we get to a, and then we jump to on.
Okay.
Does that idea kind of make sense?
Yeah.
Okay, so that thing's what's called a heaviside function. So use it to turn things on and off, which, of course, we always want to do in engineering because engineers just love a switch and a button. Right?
Yeah.
I mean, you've got to, right? There's nothing better than a big button. Or like a huge switch that you have to use 2 hands to move. So if we're going to build engineering things, like with big switches and buttons, we're going to need a way to model switches and buttons with math. And so that's kind of what this does. This is just on and off, right? And so if I wanted to restate my f of t, I think to myself, okay, so it starts at 1, right?
Mhm.
So it's 1 regularly. And then at time 4, something happens. So there's a switch activated at time 4. Oops, my writing's crawling because I'm not. Okay, so I'm thinking about my function f of t, right? And so it's 1 at the beginning, and then at time 4, something turns off. And the way you turn things off is you subtract. So what do I want to turn off at time 4? How about this? At the between time 0 and time 4, what's happening? What's the function that's on?
1.
1. Okay, and then at time 4, I want something else to happen, right?
Yeah.
So the easy way to get something else to happen is to turn off what's happening and turn on what you want to happen. You guys with me?
Yeah.
So this is going to be the off part at t is 4. And this is going to be the on part at t is 4. And the thing that I want to turn off is what's happening, which is just 1. And then the thing that I want to turn on is
T.
perfect.
Yeah.
And then I haven't taught it to you guys yet, and I'm not going to go through the process just yet on these. I've got some videos for Laplace transforming these, but these are things that you can look up in the table.
Okay.
So this is an alternate method. You can either go through the kind of practice of breaking this thing up into its pieces and dealing with the kind of switching things around, right? Or you can go look in the table for these unit step functions, which is, by the way, what this thing is called. This u is a unit step. Kind of makes sense?
Sort of.
Ish. Okay, so the unit step functions are a thing for maybe another day. But did you want to see the other one, Glenn?
I mean,
I don't mind.
if you don't mind, sure. Yeah.
Yeah, let me pause this. I'm going to pause this recording.